to be asked by ICRISAT to come to this 40th birthday party. In fact, I'm remembering how excited and honored I felt when Dr. Jim Ryan, the DG at that time of ICRISAT, gave me the opportunity to be the soil scientist representing ICRISAT in sub-Saharan Africa. And I felt so honored to have that opportunity. And now I see many of you here who I had the opportunity to work with in those years. And I think we're on this grand journey together to try and improve prosperity for the dryland tropics and the farmers there. Particularly, as we heard earlier from Dr. Adesina, the youth that we have to be thinking about. We're going to have to deal with the changing world, as I'm going to be talking about in a minute. So I really appreciate this opportunity, and it's great to see some friends here, and I hope future friends as well. But I do want to give you one opportunity to leave if you want to, because it is going to be about soils and crop physiology and such. So if you thought you were in the market innovation section, you can leave, no harm in that. I will be talking about how we can sustainably intensify, how we can link to markets, but the focus will be more on the resilience, which to me, not surprisingly as a soil scientist, comes back in a way to resilience, so just so you're aware. So it is indeed a rapidly changing world. We hear a lot about climate variability becoming more variable, but also we have to remember that the smallholder farmers, just shown here, that we have worked with over the years, we thought their situation was extremely challenging 20 years ago, perhaps, or more, some of us, when we first started working in the region. But, in fact, on the one hand, there's more opportunities sometimes for new markets, but in the other case, input markets vary tremendously. Our ability to link to them through subsidies does change up and down. We also have to be aware of this changing world in terms of land ownership and access, which I won't be talking about, but are very important, and connectivity. Okay, thanks. So this is just a quick reminder of the staple crop price variability, even more so when we talk horticultural crops. This is a price index for different regions in Africa. And this is what farmers are facing, particularly the last 4 years. I mean, some people say this is some of the basis of some of the turbulence around the world, that we have this really rapidly changing price availability. The other, one of the big global changes going on, this is a summary of about 19 climate change models reported here in this review. All of them, all but one in this case, were predicting tremendous increases in temperature in the next 50 years. Shown here is the darker red is the areas where are going to keep getting warmer, so that's a big challenge. I've shown for Africa, but in other parts of the world. Precipitation response is a bit more variable, particularly in some areas. East Africa, we may be getting wetter, drier perhaps in southern Africa. However, we have to remember that it's actually variability more than changes in total precipitation. And these are extremely variable areas already. And so as you get into more erratic rainfall, huge rainfall events, flooding, this is another area that we need a lot more options in terms of resilience, because farmers are facing, in a variable semi-arid tropics, they are going to be increasingly variable over time. So the same rainfall, but distributed differently, which can spell disaster for farmers. So ingredients for resilience, and this is what I'm going to give my list of recipe for resilience, but there are many others out here. I'll make a case particularly for the diversity aspect. There's also natural resource health, particularly soil health, but water quality and quantity. And we cannot forget local innovations. Adoption over the years of different types of technologies has always involved innovation. And more we're realizing we need to support innovation rather than yield gains per se. So the diversity includes not just species diversity, shown here, different legume species, but also innovations in terms of diversity of organisms, but also other resources, and then local innovation. Farmer here in Mozambique, conservation agriculture is getting a lot of attention. And one of the things we should not forget is that where it's been adopted is where farmers have worked with input and implement dealers and have been able to innovate and change for their particular circumstances. So to step back for a minute, what are our dominant farming systems around the world? So why do we need diversity? Well, what we have is more and more simplified cropping systems, even in Africa, where smallholders use a diversity of crops. But in many places, we have basically cereals, such as sorghum millet, livestock systems, rice, wheat, and wheat systems around the world. We also have maize-based systems in the Americas and southern Eastern Africa, in some areas increasing in West Africa. So these are dominant systems now and increasingly simplifying, which is a bit worrying when you think about where nitrogen and phosphorus come from. You think it comes from mining. Yes, but it also comes from the plants mining and using that nutrients. So let's look about functional trade-offs. I warned you there would be some crop physiology in here, but I'll keep it short. All right, so we have C4, that's a type of synthetic efficient pathway. C3 grasses such as wheat and rice, so maize, sorghum there. But there is a trade-off inherently, and this is why people think, why can't people just grow more legumes? Well, they face the fact that as you move into more high nutrient dense oils, the proteins and so on, you inherently, because of the cost of that, the photosynthate it takes to go below ground, often estimated around 40% just to support the nitrogen fixation, for example, that allows the protein and oil-rich grains and pulses. You have to grow slower. There's no such thing as a free lunch. Well, there is some. I mean, some breeders have developed some pretty amazing efficient crops, but still there's this inherent trade-off. So we need these C3 and C4 grasses to give us the calories that people need, and this is why they grow so many of them. But we also need, for nutrition of the soil and of the people, we need legumes. And I also want to make a case today, we need semi-perennial legumes. In other words, things that grow for a full year or 2 years. Something that is able to invest in a lot more nutrient-rich tissues, which I will talk about. So this allows us to have the productivity that then the grasses can mine and produce into calories. So we need both, I would say, but there is an inherent trade-off. And when you grow slower, there's the issue of less calories produced sometimes, but also there's the issue of if you grow slower, you can't get always above weeds and so on. So these tend to be more labor requiring as well. So there's inherent trade-offs that we need to be aware of that. And it seems to me that agrodiversity is missing, that we have some functional missing groups right now as we simplify our cropping systems, that we need more options. So this is a challenge to the breeders in the room. We need more options for marginal areas and also to the policymakers. We need to be thinking about, in order to get soil carbon, you have to have roots. We need crops with deeper rooting systems, and we need the one that provide vegetative cover to protect the land. Because whether you're into conservation agriculture, or we heard today, organic agriculture, you need enough biomass in both systems to make it work, and also, of course, to feed. We need them to feed livestock as well. Legumes to provide nitrogen, and this is becoming, it used to be controversial, but it's becoming well known that certain legumes also access phosphorus. Nitrogen fertilizer efficiency is about 50%. Do you know how much it is for phosphorus fertilizer? Only about 50% of nitrogen fertilizer gets used. How much of the phosphorus? 10 to 15. Oh, I say 20 to 25 to be conservative and to protect myself, but you are absolutely right. It's more like 15 in many places. So we put all this phosphorus fertilizer and then it just builds the total phosphorus supply. It doesn't actually ever get used again. It gets locked away. So legumes are essential to access and actually use it efficiently. So we can talk about triple services. We need certain types of crops for resilience, for food, and for fodder. And I did not add this slide after our talk today from the minister, but I just happened to mention first, sorghum and cassava, we heard, were very important opportunities in terms of fermented beverages, in terms of post-harvest use for starch and so on. So there's multiple uses of these different crops. Sweet potato, more of a perennial. Sorghum traditionally was grown as a ratoon and grown as a semi-perennial. So these can grow in very marginal areas, soils that nothing else can grow in, with their deep rooting, and both in drier areas, sorghum and cassava, and wetter areas. So I think they deserve more attention in order to have options for these marginal areas. But I also want to make a case for two crops here. One is a perennial lupin. And not just this particular crop, but this idea of a crop that puts tremendous amount of resources to access phosphorus. And then our own pigeon pea, Cajanus cajun. And people think it's because I work for ICRISAT that for some years that maybe it made an impression on me because I've been such a promoter of pigeon pea. So my students say they can count 10 to 30 pigeon peas per presentation on agriculture development I give, but that's probably, they're probably exaggerating. Maybe not. So pigeon pea, you're shown here with groundnuts, does also have this ability to access phosphorus as well as fix more nitrogen because it's there longer. So even climbing bean, if you are some sort of bean, other types of legumes, even if they fix a lot of nitrogen, like 80% nitrogen, because they're only there for 4 months versus up to 11 months or even longer in ratoon pigeon pea, it's just inherently you only have 50% of the capacity to fix nitrogen because it's just not around long enough and you don't have deep enough roots and so on. So these are some options. Perhaps we could be exploring them more, but not to totally disregard the short duration annual legumes that are so important for food and nutrition of children, early crop, confectionery use of groundnuts and so on. So, and soybean for poultry and industrialization. So we need these, and all legumes are not the same, which shouldn't come as a surprise to you, but sometimes it is a little bit surprising that development projects will say, we don't use soybean here, it doesn't grow here. Well, which type of soybean for which type of window opportunity? Are you talking about indeterminate forage, multi-purpose types? Are you talking very short duration? Pigeon pea, soybean. Soybean can actually grow in very acid areas, so it really depends on the variety and on, of course, the genus. So also legumes are not alike, and we vary in terms of going from the more agroforestry types to the semi-perennial. I'll show you a bit here. We have a combination here of soybean plus pigeon pea called a doubled up legume system, and then, of course, our annuals. And just to sort of summarize that point, that there is a trade-off, right, in terms of that maize grain legume rotations, which is, after all, built, especially in the Americas, the productivity of maize. We can't forget soybean is there in Brazil or the Midwest. Maize doubled up legume systems, which I'm going to show you a bit more in a minute. And then agroforestry systems give us the most nitrogen, but obviously often very little to eat or nothing. Maybe some fuel wood. So a doubled up legume system, in case you've never seen it, in India there's some areas where farmers traditionally use this, but usually with groundnuts and pigeon pea. But here in Malawi, we've been promoting as a soybean or groundnut or cowpea or dry bean. All of these can grow as an understory, and then we have the overstory of the pigeon pea. And the nice thing here is below ground inputs as well. But what about resilience? What are we talking about when we say resilience? Well, if you only take one thing away today, this is what I want you to see and think about. And that is yield stability. In a changing climate, this is based on thousands of on-farm trials in Malawi. And then I'm looking at a subsection from southern Malawi, which is much more marginal in terms of very high population density, very depleted soils, and so on. Now, maize is famously variable, very productive some years, and this is coefficient of variation, not yield. So coefficient of variation shows us that maize in general, these are on-farm trials, and they're somewhat better managed than maybe typically on-farm. You can get 30, 40% CVs, so around 20%. However, if you add fertilizer in the countrywide trial, and typically you can see fertilizer reduces your coefficient of variance. It's one of the benefits. You add fertilizer, and maize actually is able to survive drier conditions. It grows better, the roots grow better, they can acquire more water. So water use efficiency goes up. We heard about in the future, and more, we have to think about water use efficiency. So maize fertilizer is a good way to do that. But in the most marginal environment, not so much. Maize intercrop at half rates of fertilizer over time, a maize intercrop with pigeon pea, of course, but some other examples, but we put them all together here, did not improve their resilience. It did not improve coefficient of variation, because we want a low coefficient of variation, right? We want the maize to be more stable. A rotation system also at half fertilizer rates, again, because you have the legume there, so you can be more efficient in terms of fertilizer, but you're not getting improvement in stability. But when this rotation plus system, we're calling it, which is in this case with either pigeon pea, or we also looked at mucuna, maize after a doubled up legume system or after mucuna, you really get improvement in fertilizer efficiency, but more importantly, stability of maize. So basically what we're seeing is that you get a somewhat more resilient system if you can get an occasional shot of legumes. And this would also, long-term trials have shown that agroforestry works as well, but the challenge is farmers just have not been able to adopt agroforestry, probably because you're not getting the grain legumes that you get from this type of rotation plus system. So the benefits that we're getting include more cover, deep rooting, the nitrogen fixation, and as I said, the access to phosphorus. But not just pigeon pea, you could also get it from tawi, perennial legume, but it's used for a forage in the Andes here. So different, and also lupin is used, annual lupin in Australia, where they have very poor soil. So around the world, when people say you have to have fertilizer, yes, but let's use it efficiently, and let's make sure that we are using the abilities of legumes to access that fertilizer and be able to improve stability of production over time. And there's traditional systems in the Andes in Australia and here in India where I think pigeon pea and tawi have been providing that service, perhaps not somewhat under-recognized. And there's other legumes, groundnut, in this case, just a short example, in fava bean, when you put a barrier between maize and fava bean, and this is work from China, then you actually see not much phosphorus uptake. But if you have no barrier, or even a mesh that allows mycorrhizae but not roots, that very clearly we start to access more phosphorus. So this fava bean intercrop with maize, this traditional system, has these, again, some evidence of this benefit. Also, here's what we call a radar chart, just a way to present data from all at once, because we have to start thinking more and more about cropping systems for their multiple benefits, not just their yield, but the stability of yield over time, not just the grain yield, but the biomass. So here, the biomass going up to 10,000 kilograms per hectare, and here maize yield up to 5,000. So this is a way to compare many different studies. I'm just showing one here, for example. In fact, we've been looking at a large number of diversity experiments from Africa. We haven't been able to find any conservation, a few conservation tillage, but very few full conservation agriculture examples, which has been very unfortunate. There's been very little study of those different conservation ag referee journal studies, multi-site, and so on. But anyways, we do have this one crop diversity one that I want to show as an example. The groundnut pigeon pea intercrop, that's the doubled up legume system, rotated with maize, gives us more protein yield, more resource use, rain use efficiency, water use efficiency, biomass, highest from the trophosia, from the agroforestry. But there's this issue that, again, no such thing as a free lunch, that in fact, there is this challenge that in a rotation system, you get the maximum fertilizer efficiency and water use efficiency, but farmers, of course, are constrained by the fact that you don't have maize every year. So people with very small areas aren't able to use that necessarily. But as you'll see in a minute here, you can actually support farmers in innovating, in making adjustments to the principles that we're bringing to them. And so the last part of my talk is going to be about participatory action research as a way to support innovation, because I really don't think there's silver bullets. I think most of us agree that there's improved technologies, what we can call best bet options, that through on-farm participatory research or through different innovation systems, platforms, that we can support reviewing results and learning together about things, farmers and extension and researchers, to address these opportunities or niche windows and come up with better bets over time. And finally, we see farmers innovating, ICRISAT hat here from my past work with groundnut, and adopting, but only adopting what they see as a sensible and profitable system that works for them. And what we need to do is make sure that the systems also work for long-term sustainability in the environment. So there's one slide on one approach, there's many others, to a participatory approach that I developed while I was here at ICRISAT, and that was a mother trial where we can look at processes like nitrogen and phosphorus controlled by researchers long-term. Farmer design, I call this central satellite, by the way. It was a farmer that named it mother and baby because he said these were the babies, these were what he was going to experiment with his friends. This is where the researchers, even though it was on farm, the researchers controlled. But I think we have to focus more and more now on farmer innovation. So the grandchildren, really finding where we support farmers in applying the principles and best bet options that we've developed. So the point here is not so much to measure yields, or in this case, calories. I'm not going to go through this so much as just to show we need to think about how technologies perform, again, over different environments, just environmental index. And again, the double up legume, pigeon pea, and another legume performing a bit higher across all of them. But it's not this so much that matters as farmer innovation. So they take something like we recommended this annual pigeon pea with groundnuts and double up legume, and the farmers in this part of Malawi actually came into the next step and said, no, we want to ratoon it. We want to try the longer duration and even combine that with short duration or early pigeon pea. So we need to try and support farmers in innovating and doing it their own way. In this case, they wanted the forage and not so much for soil fertility, even though, of course, you're soil scientists are hoping to see that. No, they wanted to trade the forage, the biomass, for what? Milk. Sounds like your milk white revolution here. They wanted to be able to trade some of this biomass in order to be able to link to some dairy schemes in the area. So they're coming up with their own innovations. One other example I'll give, where showing it's not just a Malawi-specific example, but banana bean systems. Again, coming in, some researchers came in with best bets, Vacuna and Cordilleria, again, semi-perennial or at least long-lived viney legumes. The researcher recommendation had to do, you can tell they're soil scientists, about green manure and improving maize that way. But farmers then went on to figure out they could use it for pest control for their beans, boundary plantings, cooking, so processing the vacuna into a food, which they do use in some parts of Africa, and then animal feed as being a very important option. So I think whether you're interested in soil fertility or livestock productivity, I think it's supporting farmers and innovating and getting in some, kind of higher biomass and soil improving options that then farmers can use in different ways. We need them for all those different farmers. But we can't just use anyone. We have to make sure that farmers are supported with best bet options and government policy is supported. And so one thing we've been going back to some of the work that ICRISAT has supported over the years with APSIN modeling is we're trying to make sure that there's some areas where you can't bring in even pigeon pea. I love it because it might use up all the water. So what is the trade-off between nitrogen fixation and water use? So we're doing some modeling, trying to see, and combinations, the microdosing of fertilizers, compost, and diverse crops, and trying to see where these might fit in the landscape and look at variable weather patterns and interact with farmers to see what are their thoughts on different options and how they perform. Because we want to make sure you can see from using historical weather data for different places, in Malawi in this case, continuous corn does use less water in the orange here. Maize pigeon pea rotation uses a lot up, but fortunately, usually it is the water, enough rainfall rejuvenates the soil water profile. And another issue that you can see with modeling and hopefully long-term trials, but we still have very few of those in Africa in particular, is that initially, this is different soil types, you can look at those. Initially, the intercrop puts some water stress on the system because they're competing with the maize, so pigeon pea maize intercrop in this case, and the rotation does too. But over time, so this was, the models run over 10 years, so towards the end of it, we in fact saw reduction in risk. So most of our experimentation is done here, 2 to 3 years, as many donors have that much patience for on-farm research. We often don't get to the point where we've reduced risk up here. And so this can be seen here. Again, most of our experimentation is here, where from modeling you can see that really improvements in productivity. This is maize plus 24 kilograms of nitrogen. So even at half rates of nitrogen in the intercrop and the rotation, you have much higher yields because this is very much a nitrogen-driven system. But over time, the benefits become much clearer, and we can get at this through either long-term experiments or modeling to try and see where it works elsewhere. So I see the model opportunities as providing sensibility analysis, not just sensitivity, which is how we test models, but sensibility to identify these best bet options. Understand the trade-offs, because we can't be promoting things that will take up too much moisture and reduce the main crops like cereals. And to develop, sometimes we call them decision tools, but we could even call them discussion tools, right? So we end up with farmers, such as this lady here, who has not, it doesn't look necessarily like a recommended experiment, but with our nice rows, and I see signed in on, but you notice she has a really leafy soybean, and she has a pigeon pea growing here and there, Trifossi in the background. So she's doing her own way of trying to incorporate these different biomass producing systems, and well, triple products in terms of biomass, in terms of soil fertility, and then she can grow maize after this system. So she's trying to see how it fits into her system, and we need to be supporting her for that. Finally, I'll leave you with these ingredients for resilience, to revisit them, diversity, and I've given you one example of diversity, but I think we also need more drought-tolerant options, and not just options, but mixtures, because farmers have been using mixtures, and I think we've lost them, and our focus on fertilizer, hybrid maize, for example, in Malawi, Rwanda, and Tanzania, there's been some loss forgetting that actually fertilizers have been used more efficiently, whether we talk Asia or Latin America, or even some parts of Africa. Fertilizers have been used more efficiency on mixed systems with the right diverse species for centuries. And we have focused much more on every time you add fertilizer input, suddenly you have to go to a sole crop, and that is really not necessarily true. And then that will help support our natural resource health, improving water quality. I remember being at a nitrogen meeting in Mali, and there was a number of experts from around the world about nitrogen. They were coming from the parts of the world where nitrogen actually contaminates water, and they kept focusing on that. Those of us who worked in Africa for a while were saying, no, the more nitrogen you add, the crops grow better, at least the cereals, and then you get better land cover and you protect the environment. So I think we can say that natural resource health can be protected through strategic investments. And then most of all, we need to, like this farmer who's come up with his own way to be able to do soil conservation and check the contour of his land. We need to develop these discussion tools and better options for them that then through participatory action research or participatory extension and innovation systems platforms will be linked to private sectors, as you're hearing in other talks, and linked to farmer organizations so that we can support that local innovation, because without that, we will not see these technologies used by the smallholder farmers. Thank you.
share. Sid has just taken us through what she considers as resilient smallholder farming systems with very, very interesting examples. She has started with giving us some challenges which we need to address. She has presented her own ingredients for resilience, and she has mentioned 3 of them: diversity, natural resources health, and local innovation. She has also given some very good options and trade-offs with respect to resilience and focusing on biomass yield and yield stability. And she has ended up